Are we good?
Yes.
Okay. Okay. So we're doing the. This is just a presentation, okay, of like more in details your steps for your Ohms Law Lab. Okay. It looks like a big lab, but it really isn't. It's really simple. Okay. So you need 3 circuits, right? So you need 3 resistors in series. You need 3 resistors in parallel, and then you need one of the compounds circuit. So let's draw. So there's 2 of them. So it doesn't matter which one you pick. Both are fine. So that is the first one. Okay. So you see that 2 in parallel, and with. So I'll call it. Just respect the same colors. Right. R1, R2, R3. Right. Okay. So you guys see that? So 2 in parallel going in series with the third one. And then the second option, it doesn't matter which one you pick. So 2, right, so 2 in series, and then 1 in parallel with those 2, this way. Okay, so you got these 2 options. So it doesn't matter. R1, R2, R3. Okay, so let's keep going. Okay, so you need 3 resistors, it's pretty obvious. Okay, so the general setup is your 3 resistors have to be between 1.5 and 15 kilo ohms, roughly. So why not go too low? Why? So you want them to be around 5K-ish. So why not go lower than 1,000 ohms? Well, it's for this reason. Here, if you go in parallel, if you put, like, for example, the 12 ohms here, what's going to happen is the current going through 12 ohms and a 9-volt battery is going to go pretty high, and this battery, you're going to drain it super quick. And it's even worse than this, okay? I did explain to you guys, how do we know that a battery, the state of charge of a battery, how do we know? You check the voltage. So that means, as you're doing, so say here, you're using your 9 volts here for this circuit. If you have a really low value resistor here, current's going to go quite low, like in the hundreds of milliamps. And these guys are going to drain pretty fast. And then as you make your measurements, right? Because remember, right? As the battery drains, the voltage drops, right? But if the voltage drops, that means the currents also are going to change. So if you go with a really high current, your values are going to change live as you're measuring. What does that mean? That means your precision for your results will go bad. Okay, so I'm trying to get you guys to pick just the right values. And if you pick too high, like 15 kilo ohms, it's getting high actually. I would keep it lower. Okay, really the best spot is between 5K and 1K-ish. Okay, around these values. Okay, if you go to a too high value, what's going to happen if you put like 1 mega ohm here? What's going to happen to the current in series? There's not going to be any current because 1 mega ohm, it's super high. So this thing, guys, is not infinitely precise, right? Makes sense? So if you have like a current of 10 microamps, like you're getting really low now, right? And this guy, you won't be able to make significant measurements. Make sense? Okay? All right, so that's why you want to be in a given range, okay, around those numbers. So what I picked yesterday, so if you take your booklet, it's on page 4 or 5. That was for effect. Well done, Mike. Do we have him come like his face just on the table? So for, okay, no, we're not going to do. Okay.
Unless you give us permission.
That's right. Okay. Okay, so you pick 3 resistors in that range. So you have, okay, so you know how to read the color bands, right? Okay, so the gold is on the right? So if it's not on the right, you turn your resistor so it goes on the right, okay? And then you check. So this one here, gold is here, Okay, so I got brown, red, red. So I go brown, 1, red, 2, and then the third one is my multiplier. Red is 2 zeros, right? So that's 1.2K. Does that make sense? So this is perfect. So I'm going to write this down. This is my first one. 1.2K ohms, right? What's this one? So yellow 4, violet 7, 4, 7, orange 3. So what is that? 47K. That's really high. Okay, so I'm not sure I like that. That's too high. Okay, so you pick one. Oh, here's an orange here. I probably want red. Okay, so here. Okay, let's try this one. So brown, black, red. So 1 brown and red. So this is 1,000. Yes. Okay, so this is pretty good. I'll use that. This is supposed to be 1K. And then what was this one? So yellow. So 4, 7, 2 zeros. So that's 4.7. So this is perfect. Okay, these are good values. Okay. If you are not in this range, come at the front. I got resistors. Okay, so we can give you missing resistors. That's fine. Okay. So do I just start now with my circuit on the breadboard and the battery and so on? Is that what I do next? No, that is not what you do. So what you're going to do? What's the problem? You're going to measure. Exactly. Good call. How come you know that?
Just get more guy.
That's a good call. So why don't I want to use those numbers right away and just pretend that they are at these values? Well, it's pretty clear. It's because none of them is going to be exactly at this number. Your goal of your lab, guys, is to get as close as possible to what you should have measured, right? So why are they not exactly on the numbers? Well, because they can't make them super precise. So what do? Take the ohm meter, so you go on ohms, right? Ohms, the horseshoe. You take your resistors, and then you measure them, and you obviously, that's good, and then you obviously write it down, right? So you try not to touch the probes. Although those are low values, they won't make a difference. Let's actually test it right away. Okay, so you see how close this one got? So 997. So that's pretty good. So this one is actually 997 ohms. Sorry. Okay, that's good. This one, oh, I wanted to test, my apologies. I wanted to test if we can see the difference. I really doubt we'll be able to see it. So 997, and now without touching it, I don't like doing it this way. You get really. Is it because I'm touching it funny with the probe? It's probably that. Really. Okay, I'm actually surprised about that. So see, now I'm reading 998. Okay, so yeah, it's inconclusive. Okay, so it came back to the same number. I don't think on low values you can really measure your skin. It's on the higher values that it will make a difference. Like when you're in the mega ohms, because your skin is in the mega ohms. Does that make sense? Right? So you can't read your skin when you read those. It's too low. So these guys, come on. Okay, so, right? Like they don't sell garbage, right? Like 1.201, right? Like how close is that? It's supposed to be 1.2, right? And see, it's going to, so it's, okay, so this one is oscillating between the two. So 1.2, so this is 1.201K. Okay, do you see what I'm doing? I'm keeping track of what's going on. So what does that mean? Do you need to have a sheet with some results for yourself?
Yes.
Yes, right? Do you want that sheet to be all disorganized, messy, so that you can't make sense of it?
Probably not.
Mike might want it like that. Okay, I'm being silly. Okay, you look really sleepy.
He never
I-
sleeps.
Okay, you're on roll here.
Busy doing stuff like that.
Okay. So last one, 4.7. 4.7. So 4.65. Am I going to read a different number if I go without my fingers? Not even. Okay, so you guys see that? I actually get the same number. So you are fine. So, whoa. So 4, 6, 7. Guys, just bring it up. What's the concern?
The first one?
Yeah, keep going. This one here?
Yeah, is that going to be 0.997?
Yes. No, but now I switched it to ohms.
Oh, okay.
That was kilo. That was kilo, right? So I switched it to this. Okay, so what is this going to do to your numbers when you're going to make your theory? Wow. So these are really important measurements to do. Okay, we're good? We're good to go. So this is your first thing to do. Because there are many of this, many of this, many of this. So what does that do, guys? What does that mean? I have some masking tape, okay, and scotch tape, okay, and you guys figure out how to do it, but these you should only work with these for today and tomorrow and Monday, and maybe even Tuesday, because otherwise you're going to have to remeasure those. So you're going to tape them, right, like just the legs, right, like together, right, and say like, for myself, I'd write broder and then toss it back in your box at the end of the day, right? So that you know these are the ones you're working with. Make sense?
Yeah.
Okay, good. Okay, let's keep going. So I think I'm ready to go. I think I'm ready to start, okay? Okay, so let's connect our 3 resistors in series, okay? So I go, right? So this is my series circuit. Maybe just highlight here. So this is what we're doing. Okay. Now, when I have drawn those, I haven't put the battery. So where does the battery go? Just at the terminals, right? So here, here, and here, here, right? Like I just didn't draw it, okay? Okay, so you go like this. Okay, so this is the part, right, that you guys need to zoom in here if you can. Okay, so my first one. Okay, always keep them in... oh, they're not even in the same order. That's my last one. That's my first one. Okay, so I'll keep them in the same order, right? It's good for you guys, right? Like don't make it hard on yourself, right? So here, say, and here. Okay, so are you guys seeing this, right? Okay. Okay, and then here, can I reach? It's getting far. Okay, this is in, this is in, this is in. Okay, take a nice close-up of this because that's the part that kids get wrong. Okay, so notice they're on the same lines where you need a node, right? Okay, good to go. Easy enough. My battery, maybe stay here for the battery. Okay, so I find my line, connect here, find my line, connect here. Okay, so now my circuit is ready to go. Okay, remember, never work with your battery connected. Connect at the end. Safety rule, think again. I know this is exaggerating here, obviously, but build it as a habit, okay? Like, create the habit. Okay, so I'm ready to go. Turn this on. Is there a current going on now? Should, unless I have a bizarre connection. Okay, so you go volts. Okay, so keep it in the same sequence, right? So do volts and then do currents, okay? So you go volts. So here you have to be careful, measure right at the battery. Okay, just a point to reflect on. Is this here going to give me the same volts? So let me bring this close so you guys see this. Right? So 7.81. Am I going to read the same if I go straight at the battery?
Yes.
No. I did explain why. So VT 7.81. That's though at the resistors. This meter is not super precise, right? Because it's got, it can only play with 4 digits. But I should pick up, yeah, it won't pick it up here. No, so it's not picking it up. Okay, so 781. Okay, so you were right. We're not going to see the difference. But I just want to prove something though, my point. If I measure from just the volts difference on this wire, okay, they're really annoying. Okay, I'm reading some volts drop here. Okay, so 2 millivolts, 1 millivolt. Okay, so there's a bit of a volts drop. Why is there a volts drop on my wire? Is it really at the wire? It's actually at the connection, right? We did talk about that. That's because inside the connection is not very fancy. It's not very good. So what would happen if I drove really high currents to this circuit? Like the connection would heat up real time, big time. They would, okay? Because there's quite a bit of resistance there. Okay, it's not kilo ohms, but it's enough to show up. Okay, so that's my VT. So now I just go. I'm still in my first one, right? I'm still in my first one. So my V's are going to add up, right? So you measure them, okay? So that's my V1. Now, do you understand why it's important to keep your resistors always in the same sequence? Right? Because otherwise you'll get confused, right? Like now, is that my V2 that I'm measuring? Right? So call your R1 always the same value, basically, right? Because your V1 is connected, and then your I1 too, right? So help yourself. Don't make it messy. Okay, so now I would write this number, right? Make sense? So 1.143.
It turned off. 'Cause my battery's-
Nice. Good move.
Ooh, because they said no more storage.
So it's your phone's fault, right?
Yeah,
Right. What was it?
it's okay. I got most of it. I got a good part. Yeah, that's just clean.
So 1/4. Yeah, forget it. That's okay. Okay. V2. Okay, you see what I'm doing, right? I'm just measuring my numbers. Right? So 1.376. Okay, and so on and so forth. Okay. Now, what you're going to notice is they're going to add up. Okay, we talked about that already. So 530.
Mr. Bridger, can you measure the last one again?
Last one here, 530. Yep. Okay. So C. So what's wrong here? Don't forget your units. Okay. So notice 1 plus 1 plus 5, right? Plus a bunch of decimals. If I were to punch my numbers, I should get pretty close to this here. I should, technically. Okay, because the rule in series is VT equals V1 plus V2 plus V3. Okay, now that we know that, my next step is to measure my, what's the next step? They don't?
No,
They don't add up?
No, I didn't have them last time.
Oh, I thought that's what you were doing. You can do it. Like, it's okay if you do that. So what's my next step? Guys, I'm trying to go quick. I don't want this video to be the whole period. Let's go.
Measure the current.
So now I'm measuring my current. So when I'm in series, what do the currents do?
Current is constant.
Current is constant throughout. It's the same. Not so much constant. It's the same. Okay? I know what you mean, but it's not really the right word. Okay, so we're going to go IT. And so now this is where some of you, right, like you're going to hesitate. How do I actually measure this? Okay, so let's actually highlight here, Samin, okay, the procedure that I'm doing right now, okay? Because I want you guys to not break the tools, right? Okay, so I go in milliamps. Okay, so I'm going to go to this one. Did I measure my theoretical current that I'm going to have through this circuit? Did I do that? No. So to be safe, because I don't know, maybe highlight here, we talked about it. This probe, when I'm measuring current, I'm reading max of 400 milliamps. What's going to happen if I bust that number? The fuse inside the meter is going to blow. Okay, so what I do to be on the safe side, to start my measuring of current, I go on the 10 amp side, okay, right? And then I use my probe, and then when you read current, you need to cut open the circuit. Do you remember that? Cut open the circuit. So it doesn't matter if I go plus or negative. It doesn't, right? Because the current is the same throughout, right? So it makes no difference. Okay, so I can make my IT here. Makes no difference. Don't touch the wires. Although this is not dangerous at all. Okay, so do you see the issue here? Okay, Samin, are you picking up the meter?
Yeah.
I'm reading 1 milliamp right now. So what do I need to do? And it's actually going back and forth. So I'm safe. Does that make sense? I was just showing this because this one has a rating max of 10 amps. right? So I'm safe. So now I go back to the finer reading, because otherwise you'll blow the fuse.
So is that one more precise than the?
That's right, because you lose precision as you read bigger numbers, basically, right? So I'm going to go on the 400 range, milliamps, so that's fine. So now measure this again. Okay, so hold that, and then measure here. Okay, so see, I'm reading 1.14 milliamps. Okay, so notice I interrupted my circuit, right? I cut it open, 114. So what are we expecting? What are we expecting? Now, don't forget your units. I got kids that write, oh, hey, you know what? Big resistors like that got 1.14 amps, you know, right? Like this is like seriously, right? Like guys, write your units, okay? Like if you give something to me where you got your units wrong, that's not going to go well. Okay, so what do I want to do now? I'm supposed to read I1. So now this is where I would interrupt. Okay, so I'm asking you that you check it. We know it's going to be the same number, but still do it for your sake. So I interrupt the circuit at the end of R1 and touch here. And then notice I'm getting 1.14 again. Write it down. All right, so you go I1. And then I know it's tedious, but then you do it for R2. Okay, so I'm not going to do it now because it's just the same. Okay? Are we clear on this? Okay, so I am done right now, my measurements for my first circuit. That's all I've done right now, my first circuit. Okay, so now second one. Okay, so I'm going to erase this. I don't erase my values of my resistors. Disconnect the battery. Okay, so now how's this circuit going to look? Okay, so I put them in parallel. So this is going to be in parallel now. Okay, I'm going to have to make my circuit a bit tighter because these are getting quite spread apart here. Okay, so maybe focus in on this. This is what parallel looks like. So I'm going to connect my battery, right? Maybe turn it, right? So notice this is in parallel. They're now all on the same line. Okay, so that's why we're recording it, okay? So that you guys, if you forget, you can just watch it again, okay? All right, so do the same, starts with volts and then go to current, okay? What being, like if you keep the same procedure, right? Is that going to help you if you always do volts and then current? Is that going to help you?
No.
Well, it's going to help you to not make mistakes, right? Because if you go too quick and you start swapping your numbers, right? Oh, now I'm going to start with current. You might actually put the number in the wrong line and you don't notice what you just did. And then you start your lab, you're going to be like, what the heck? Like my numbers don't add up, but still I did my math correctly, my measurements, okay? So your recordings, guys, are really, really important, okay? So by the way, this sheet with all your results, like the raw results, I will want that sheet on your lab, okay? So the rest of it will be super fancy, nice, and clean, but I want a scrappy sheet at the end, like your results. How did you measure your results, okay?
Can I just type it out?
I really would like to see it, okay? Unless you enter them directly into your thing. That's not a bad idea. So I'm not against that, that's fine. Okay, so connect your battery. So VDC, right? Okay, so now VT, do the same. My volts are probably changed. So you see that, 742. What did I have earlier? 5? It was different.
7.8.
7.8?
Yeah.
7.8, right? So it's already down, okay? So 7.4. Do you see the numbers? Simon, are you taking the meter down?
Yeah, sure.
Notice what's going on. My numbers are losing 1/10 of a volts every like 5 seconds. The battery is literally draining right now. okay? Because it's also weak, right? Because 7 volts, that's getting pretty low, right? So the battery is not able to really hold the voltage. So like it's on its last leg right now, okay? So now what that means is I have to make my measurements as quick as I can, right? So it was 7.4, but it was already at 7.37 now, right? Volts. Okay, so you keep going. So measure V1, right? So it's going to be again, so now I'm at 7.35, right? Measure V2, 3.5. Okay, you see what I'm doing, okay? And then you just enter your numbers. That's easy. Now what about I? Vt is equal to V1 is equal to V2 is equal to V3 in parallel. So that's easy. But what changes now? It's the current. That's right. Whoa, whoa. Thanks. Okay, so notice this is my IT, this is my I1, I2, I3, and they will recollect here, right, to become IT here. Okay, sure. Okay, so I go. So how do I measure this? Do I go, so I go milliamps, right? So do the same, double check that you're not busting your numbers. So do I go and measure right here? What's going to happen if I do this right now? This is a short, right, inside my meter when I'm as a nanometer. So I'm going to short my battery if I do this here. So I don't want to do this. So what I do is I open the circuit. This is the part some of you will do wrong, okay? I don't do it, please, okay? And then I measure, I touch one of the probes. So you see I'm reading 14 milliamps. Okay, so am I safe to go down to the more precise scales? Yes. So I go down, right? And now I should read 14 milliamps plus some decimals. Okay, so it's really cool. Okay, so it's really nice. So look at the current. It's dropping as we're talking. 1502, 1501, 15 is going to go soon, and then 4. Okay, you get the point? That's the battery dying right now. We're literally seeing the battery die as we're talking. Okay, so that's my IT, right? Because I interrupted the black wire. So that's my whole circuit. But now how do I measure? So what was this number? 14, right? 14. That's right. So 9 milliamps. So obviously keep all the precision you can. So how do I read I1? So I get resistor 1 out like this, touch the probe, and then touch the other resistors on the same side. So see now I'm reading 611 milliamps. 611, that's I1. And so on and so forth, right? This is how you read each. So you reconnect R1. I can disconnect on this side, it doesn't matter. So now I'm doing R2. Okay, so you may want to emphasize here, can you zoom in here, like how I'm measuring them? Okay, because this is the part that's not obvious, okay? So come and see right now, guys, if you want to see it, okay? It's not obvious, this part. So you see what I'm doing? I'm touching the resistor here, and I'm touching the other one. Okay, so I'm essentially connecting them, right? You see that? Right? So I'm creating a short. So now I'm reading 734, right? So 734. Can you guys guess my last one?
Yeah, you just subtract.
Well, this minus this minus this should give me this one, right? Right? Okay, so I'm not going to do it, okay, because we know it should be the good number. Okay? The last one, A and B, I am not showing you how to do it because it's a mixture of the two. Okay? And I'm leaving it on purpose. Last year's, I left it open. The goal is to force you guys to figure it out, okay? So if you run into issues, I'll be there, okay? But this is about self-discovery, okay? So this part, you have all the knowledge, but now you need to apply the right rule at the right time. So you pick one and don't change the setup, right? Like the danger is that you start this one and then the next day you do this one, then you'll be like, what? My numbers, like seriously guys, pay attention to what you're doing, okay? Can we take questions quick? because it might be helpful for the crew watching this. I can't hear.
You already answered.
I did answer it. Okay. So you pick one of those two. Yes.
What if the third current doesn't add up?
It has to add up to it. Like, if it doesn't, you broke physics. So it has to work, right? I don't think we'll be able to break physics here. Right? So go ahead, touch it. It has to work because that's a higher resistor. So 1.57. It's got to work. It seems like it works. 157. Guys, physics works all the time.
Yeah, that's true.
This is why we've shot rockets on the moon and whatnot, right? This is why your phones work. Physics always works. Comments, questions, guys. Maybe I could show how they're connected. That I'm okay to show. Okay, is that a good idea? Right, like how they would look on here. So let's show A. Let's show A. So I would take a resistor out. Okay, guys, when your resistors start to frizzle up, right? I'm not sure how to call this, right? Like where their legs are all twisting, okay? Like take your nails and rebend them straight, okay? Like it'll just work better, okay? Okay, so and then you bend it that way. Okay. Okay, so these are my two in parallel right here. And then I just add a third resistor in series, right? Sorry, I'm hiding it right now. It'll be visible right now. Okay, so now this is this one. Okay, so it's recorded. So now let's do this one. Well, how about I'm lazy? I'm being lazy. How about I won't reach? So I'll have to redo it anyway. Okay, so okay, so because I need to make them tight. Okay. Okay, so these are going to be these two. And then I just need to put one in parallel, right? So it does help if you look at the drawing and you copy the drawing. It does help. But once I'm done this one, I just want to show you that you can make them non-obvious and still get the same result, okay? So this is this one right now, right? So the battery would go at the two ends. Okay, so battery would go here. Okay, so this is this one. I flipped it though, like R1, R3 are here, right? So it should be flipped, okay? Okay, so look how I could do this one, okay? Just for sake of demonstration, right? I could make them really not, like, non-obvious, like looking a lot like, okay, so look at this one here. This one here, I just want to do it well. Okay, now I'm confused myself. Hold on. It'd be here. It'd be here. That's right. Okay, so look, this is again this one, but now built this way. Okay, so it'd be this way. Okay, so just have it nicely recorded. Yeah, I'm correct. So this is the same as this one. Okay, so it's not because they don't look the same, like that you can't make it look different. Not sure that's making sense, okay? Okay, so that's a bit more unobvious. I think that's it. Do you guys have any last thing just before we shut this? Yep.
You have to choose, you have to do both of the...
No, just one, but stick to the same. Just one, so these two, you pick one, but stick to it. Okay, so by the end of class today, it's getting late now, because that was a long video. By today, you should at least have your series, okay? You definitely can do your series, okay? All right? And then when you, one quick note, do you do one measurement for VT when you start this one, and then the next day you don't measure again your VT? Is that a good idea? No, what's going to happen to VT? It's going to change, guys. Okay, so it's okay, guys, if you change your battery during, like on day 1 and say day 2 you change your battery, right? It doesn't matter, okay? Like that's totally fine, okay? But just maybe write it in your lab, right? Like I have to change my battery. Okay, so when your battery gets at around 6.5-ish volts, like it's really kind of done, okay? Like it won't be able to keep current, okay? All right, we're good to go? I think that's pretty much it. Thank you so much.